Oh my goodness, no, stop. That is not equal to 0. Please be very careful. Don't quickly answer it 0. That's not, just because you take the limit, that exponent is a negative doesn't mean that it converges to 0. That's not true. That's not true. Okay? Be very careful. If you remember my advanced training for limits, what is the number one thing that you need to be careful of? The domain. And when I say domain, I'm talking about the bounds, right? What is in the interval of our bounds? We have from negative infinity to infinity, right? Things like this, you need to be very careful. Always watch out. Oops. Always watch out for our domain, right? Notice that, maybe I should recap. Let's recap. Why am I so careful with limit integrals? It's because x to the power of n does not always equal to infinity, okay? I'm gonna repeat myself. This does not always equal to infinity, okay? The limit of n approaches to infinity of x to the power of n is equal to infinity if x is greater than 1, okay? If x is greater than 1, then this is going to be infinity. Okay. If it equals to if x is between 0 and 1, if x is between 0 and 1, it equals to 0. Okay? So you have to be very careful. Do we have 0, 1, or from 0 to... Well, I mean, we don't have to worry about negatives. I know some of you are like, okay, what happens if if x is a negative here? It's a little complicated. I don't think it's negative infinity. It's weird because you have n. You literally have this, and I don't think it to me it looks like it diverges, but I could be wrong. I don't know. That's like real analysis stuff, but you'll never ever come across that. You'll never come across that. It's a little, I think it might be indeterminate or ambiguous, but I could be wrong. But to me, I think it's undefined. But here, we don't have to worry about that, because look, this is symmetry, right? It's an even function. So, we can just go like this, okay? Now, is it 0? No, of course not. Of course not, right? When you take the limit, oh, this is negative infinity, is the whole thing 0? No, that's not true, okay? Remember, again, limit to n infinity of x to the power of n does not always equal to infinity. It does not always equal to infinity. Please remember that. When you're solving limit integrals, be very careful with its domain. Consider the domain, okay? This is how you get victimized in integration B. You will be eliminated. So, what do we need to do? We need to split it, because it's a piecewise integral. So we need to split it from 0 to 1, and then from 1 to infinity. Now, in 1 to infinity, we know this is going to be infinity, e to the negative infinity. Now this is 0, okay? But we have this left. We have this left. What do we do here? Well, what does it equal? It equals to 0 between an interval of 0 to 1. So, oops, we already compute the limit. Sorry, we already computed the limit. So now, from 0 to 1, right, x to the power of n, right, when you compute the limit, it equals to 0 at this interval. So we get e to the power of 0. So e to the power of 0 is just 1. Therefore, our answer is 2. Okay, so the limit of this integral does not equal to 0. It equals to 2. Okay, be very, very careful with limit integrals. The number one thing I always tell you guys, whenever you have a limit integral, please look at the domain, check the domain, consider the domain of the integral bounds. Okay, be very careful. That is the number one thing that will eliminate a lot of advanced integrators, and you don't want to be one of them. All right, I hope that helps. and I'll see you guys in the next video.